Everybody, this is Surendran, and today is just a continuation of the last session. Today I'll be just taking you through introduction to sensors plus that. This is mainly for students who haven't attended last webinar session. I'll just give a brush up some concepts on last week's session, like what is a sensor, what is a DAC, how do you interface your sensor with a DAC, then to a PC. Then I'll just show you two demos with LM35 and the IR sensor, how to acquire those two signals, process it and give it to your PC. First, what is a sensor? A sensor is a device which provides a usable output in response to a specified measurement. So example, if I want to say measure any physical quantity, say such as a voltage, a current or any temperature, I need to have a device which can convert my physical quantity data into a readable format, say like a voltage or a current. So what I need to have a device which will do this operation. So I'll just go for a sensor. So sensor usually acquires a physical parameter and converts it into a signal which is suitable for a processing. The well-known are like a microphones, the loudspeakers that are present on your com or your desktop. Since sensors are omnipresent, it can be present in, it's something like it is embedded into our bodies. Say like get into a medical application, if you want to acquire any data from a patient, you need a ECG signal or EEG signal. Moving on to automobiles, you need to have a sensor. If you want to measure the fuel tank capacity, you need to have a fuel sensor. For aeroplane, you need to measure what is the pressure or what is the humidity, what is the conditioning, you need to have sensors. So all this physical quantity data can only be captured by a sensor and it is given to a DAC. So without the use of sensors, there could be no automation. So here are some of the different quantities, like say for an acoustic, it will be a wave, a spectrum or a velocity. For electric, charge, voltage and a current. So example, if I want to measure a current in a circuit, I need to go for a current sensor, which is say WCS2720, so that I can give its input, take the output, give power up supply and the ground. So these are some different domains of stimulus, say electric, magnetic, optical, thermal and mechanical. So till now sensors is done. And what is DAC? DAC is a system which is used to capture, measure and analyze some physical phenomena from the real world. It is something like you will have your physical quantity, next you will have your sensor, and then you will have your DAC system. So what the sensor will do, it will try to acquire some data from the physical quantity, try to give it to any DAC system which has a capability of processing, collecting and measuring some signals. So that operation will be carried properly by a DAC system, say like a light, a temperature and a pressure. So DAC mainly is the process of collecting and measuring electrical signals and sending them to a computer for a processing. So here are some, like say for a temperature, I need to use a thermocouple. Here the transducer is nothing but a sensor. So I can go for RTD or thermistor. Example, if I want to measure the light, the velocity of a light, I'll have to go for say vacuum tube photosensor or the photoconductivity cells. So like this, you have different kind of sensors for different field of application. If you want to measure the load, you have a load cell. Strain gauge, you have some sensors to measure pressure, humidity, temperature. So for various applications and for varied domain, you have different kinds of sensors. Today what I will be taking you is some three well-known sensors, like say LM35, which is a temperature sensor, and an IR sensor. Now last class or the last session, what we discussed is that I had a PIR sensor with me. PIR is nothing but a passive infrared sensor which has got three terminals, say VCC, ground and Vout. VCC will determine the input supply voltage of the sensor. Ground is nothing but your reference point with which you have to measure your data. Vout is nothing but it collects the data from external environment or a physical quantity and it gives the output in terms of say voltages. Now what I did is that since I had three terminals, I need to capture this data and give it to my DAC system. What do you mean by DAC? DAC is nothing but basically a system which acquires signal, process it and gives it. So here what I'm using is that the DAC which I use right now is from NI MyDAC. It is mainly designed for students to carry out their academic projects. So what is the main thing in this is that you have analog in, analog out, DAOs. So analog in is nothing but which is used to acquire some signals from external world. Analog out is nothing but if you want to simulate some signal, say you want to generate a 5 volt a pulse of on and off period to control your stepper motor or any motor. So that generation can be done from analog out. Analog out is nothing but you're generating from your system. Then you have DIO. DIO is nothing but digital in, digital out, which can even acquire, which can even generate. Next you have this plus 5 volt DC, plus 15 and minus 15. These are the main features of DAC. Apart from this, this has got a sampling rate of 200 kilosamples per second. So what do you mean by sampling? Sampling is a term. Example, if you want to acquire any signal, at what range, at what frequency you want to acquire it, so that during your reconstruction phase, if you want to reconstruct it so that you get a proper wave. I'll just give you some 2 demos on 2 sensors, and here are some of the NI based hardware. See, the first one you can see is your sound card. Even in your laptop you can see some sound cards. Here this determines your sampling rate. This has say some 8 to 44 kilosamples and the resolution is 12 to 16 bit and it has got analog in 2, analog out 2, AC or DC. It works on AC voltage. Likewise you have different domains or different disciplines of DAC, which is plug and play like a USB. It can even be a PCA or like this, like say standalone systems, oscilloscope, all those things. So if you compare here, based on your application, you can choose your hardware or your DAC which you want to. Example, you might be working with say just acquiring some 2 to 3 sensor data where your sampling is not a mandatory, so that you can just go for a hardware which has got less number of samples. But when you want to get into much more precise sampling, when you're doing a signal processing or some acquiring data, real-time data where even a single samples matter, you can just go for a high-end sampling based DAC where you'll be able to sample each signal more precisely than your NI MyDAC or your sound cards. Now I'll just take you to through 2 demo sessions. First what I'll do, I have taken a sensor which I have taken is a LM35. LM35 is nothing but a temperature sensor. This has got 3 terminals, VCC, ground and Vout. So it goes like this. I have my sensor facing towards me. The left hand side will be a VCC. Say I have 3 terminals. So this will be my VCC. This is my out. Vout is nothing but which will give me a analog voltage or a digital voltage, and this is my ground connection. So basically every sensor deals with either analog or digital. The main thing you want to consider when you're trying to connect your sensors with your DAC is that you want to know at what is the output voltage that the sensor can give. Why? Because consider your DAC might be working from say some minus 10 to plus 10. Your sensor gives an output more than 10 volts. So obviously that signal or that data can't be fed into the DAC because DAC supports only from say minus 10 to plus 10. So whenever you are choosing such kind of things, you have to have some 2 to 3 parameters in place, out of which the main thing is the voltage. To what voltage extent it can go up, and what is the voltage DAC can support, and the current factor. What is the current required for the LM35 and what is the current the DAC can provide. So I'll just show you a basic first how to acquire a signal from a LM35. So what you have to do, just go to your lab view. I'll just erase this. I'll just go here. Erase all drivers. Now I'll just open my. Now what I'll do, this is my front panel, this is my block diagram. So everyone know what is a front panel and a block diagram. Front panel is nothing but your user interface. Block diagram is nothing but which is used to do your coding or your design or your application. Now I have my sensor in place and it is acquiring some data. Now I want to log that data into my PC, or I want to see that particular data into my PC. So what I will do, what is the hardware I have right now with me is NI MyDAC. Now this NI MyDAC is a plug and play which is driven by USB. This doesn't require any external power up supply. This takes a supply from my com. So what I'll do, I'll just right click, go to Express. Under this Express you can find input. Under this you have to go for DAC assistant. So I'll just click and I'll just place it. Now what will happen is that it will just give me a pop-up window saying that whether you want to acquire or you want to generate. Now since I am acquiring it from external world, I want to go for a acquire signal. Under this it will tell me what kind of signal you want to acquire, whether you want to acquire analog or you want to acquire a counter or a digital. Now I'll acquire a analog. So what I'll do, I'll just go for analog input. In this it will further break down telling out of these which one you want to, whether you want to go for force, a pressure, a resistance or a current. Now mine is going to be a voltage. So I'll just choose voltage. So the moment till this it is done, this particular window will give you all the features that are available to do that. You have, as I told, you have AI0, AI1. These are nothing but your two analog ins. These are audio input left, audio input right, and DMM is nothing but digital multimeter. Now I'll just choose AI0. Then I'll just give finish. Now this is your window where you can just check. This particular block will tell me what connection you have done. So I'm taking a voltage. My device name is MyDAC under AI0. So this is clear. Now I'll just go for my connection diagram. In this connection diagram, this is how I have connected. Since I have told you the sensor has got three terminals. One is VCC, one is ground, and the other one is Vout. So VCC, my sensor works from say 4 to 30 volts. So I am giving a 5 volt of supply. Since here you can see a plus 5 volt, I am trying to use the same plus 5 volt and I am giving it to VCC of my LM35. LM35 is nothing but a temperature sensor. So one more is ground. So I'll just use a analog ground. Overall I'll try to maintain a common ground so that you don't have any floating values or no, you have to maintain a zero potential. Then this red line indicates my sensor output. I have given my VCC, I have given my ground. In this 0 plus, V out of my sensor should get into this 0 plus. So what it will do, whatever the sensor it calibrates and it gives me the value that is being fed into AI, which is nothing but analog in. Since I want to capture a data of analog, I am giving it inside. So once this is done, you can just give OK. Based on your inputs you have given, it will just build its own way. Now what I will do, I forgot to mention another two parameters. Since I have told the working voltage, it will vary from -10 to +10. Now here there is one more block called as time settings. This will give you 4 options whether how your sampling needs to be done. It means the acquisition, whether you want one sample on demand or hardware time, whether you are triggering from any hardware, n samples or continuous samples. I want my system to calculate continuous samples. So it will calculate continuous samples. Now what is happening here is that it will ask you two options. One is samples to read, The other one is rate. Samples to read is that number of samples per second. So I'll just give it as 1K. I want to capture 1000 samples per second at what frequency? This determines my frequency at 1K. So everything is done. I'll just give OK, and it will start building its VA based on the inputs I have set. Now my system is ready, my sensor is ready, my DAC is ready. Now since everything is ready, it will pop up for a window asking you have configured this task with a mode request to place a DAC in a loop. Since I have given there a while loop is nothing but a infinite loop. Whether you want to place this particular block in a while loop, I'll just give S. It depends on your application. If you don't want to give a continuous samples, you can go for N samples and specify the number of channels. Now my system is ready. Now I'll just go to my front panel, I'll right click, I'll create a graph. Now what I'll do, I've created a graph and I'll just give here. So it will come and I'll just connect it. Now everything is ready. Now what I will do, my system is powered up with 5 volts, it is grounded, and Vout I have given to analog in of my DAC assistant. Now what I will do, now everything is ready. Now I'll start running. It means that I'll start capturing my data. Now you can see there is a voltage variation, say from 0.25 to 0.3. It means that my temperature is varying in the scale of say 1 degree. So what I'll do, I'll just stop this VA. Why you are getting this is that every sensor comes up with the inbuilt calibrated factor. Like say whatever LM35 right now I use is that for every change in 1 degree Celsius, there is a equivalent change in 10 millivolts. It means whenever my 1 degree Celsius increases, there is an increase in 10 millivolts. So obviously you won't be able to judge what is the perfect voltage here. So what I'll do, I'll just make a small conversion. Right click, go to your numeric. So I'll just choose this multiply operator. Now what I'm basically trying to do here is that I'm trying to convert my millivolts into voltages. So what I'll do, I'll just go here and I'll connect one of the terminal, that is the terminal that needs to be converted from millivolt to volt. So converting from millivolt to volt, you have to multiply with a factor of say 100. So what I'll do, I'll just right click, create a constant. In this constant I'll specify what is my multiplication factor. Since I want to convert it from millivolt to volt, I'll just create a graph indicator. Now what I'll do, I'll just go here, I'll just place it. Now if I run, you'll be able to see here. Here it varies in millivolts. Here you are getting it in terms of volts. But even right now you are not able to see properly. So what I'll do, I'll just stop this button and I'll just go here. I'll just give it as 0 and I'll give it as 35. And I'll remove my auto scale Y. So I'll do the same operation here. I'll just give 0. Here I'll give 35. Now what happens, I'll just see. And I have removed my auto scale Y. So my system is ready. I have given say from 0 to 35, 0 to 35. The moment I run my VA, you can see now the voltage is 30 degree. It's a temperature is 29 to 30. Obviously your output, what it shows is a voltage, since I have given there as a voltage. Here you can just find the same value, it will be in terms of millivolts. Obviously you won't be able to see. Here it is converted to volts. From here to here, that conversion is happening here. I'm getting a data. Since I want to convert it from millivolts to volts, I'm just calibrating, I'm converting that by multiplying a factor of say 100 and I'm giving it to my waveform graph. This waveform graph, the first one is in terms of, the temperature is in terms of milli, or the voltage is in terms of millivolts, and here it is in terms of volts. If you want the same thing to be given in terms of your Fahrenheit, now whatever it shows is in Celsius. You have a formula T is equal to 1.8 into F into C plus 32. You can do that conversion and you will be able to see the same output in Fahrenheit. This is how you can interact with the sensor, like acquiring a signal, giving it to DAC and processing it and seeing it in your LabVIEW screen. Now I'll show you one more demo of a IR sensor. How does a IR sensor work and how do you capture those signals, and same way you can plot it in your LabVIEW. Basically, what is an IR sensor? IR sensor is a kind of a sensor which has, say, two terminals. One is your transmitter, one is your receiver. Transmitter is nothing but it will be just transmitting some data, and receiver, it will be just receive whenever there is an obstacle placed in front of that. So whenever there is no obstacle placed in front of that, obviously you won't get any, like it is something. Now what I'll do, I'll just show everything once again. I'll just delete this complete, so that once again you will have an idea how to configure your DAC whenever you want to acquire any signal. Same way, this IR sensor has three terminals. One is your VCC. This VCC is given to plus 5 volt. Every sensor input voltage varies. So here my input voltage is say from 5 to 10 volts. I'll give a DC plus 5 volts. Since in my DAC I have 5 volts. So what I will do, to my VCC I'll give a 5 volt of supply. Now one more terminal is ground. This I'll make a common ground in my DAC. The next is nothing but my Vout. Vout is nothing but which is going to give me the output. So my VCC is done, ground is done, your Vout is done. Now I'll tell you once again how to connect these three sensors once again to your N9 MyDAC. So you have your VCC you have connected, which is powered up by 5 volts, and you have ground. Whenever you try to have say 2 to 3 circuits, try to maintain a common ground, so that you don't have any any floating values or change in any frequencies. Now what I have done, I have done everything and I am tapping that Vout into my analog in. So what I will do, I'll just right click. Once again I'll just go for express. I'll just go for input. I'll just place it on my block diagram. Here also I'm just going to acquire a signal. I'll just go analog. I'll take a voltage. Overall I'm going to measure voltage. So once again I'll choose the same channel AI0. In case if you have two sensors, you may have a doubt that how can I use. Whenever you are using two sensors, the first sensor can be connected to your AI0, the second sensor can be connected to AI1. At a single time it can't capture two signals. So what I'll do, once again I'll just go for AI0. Under AI0, the moment I'm done, I'll just give finish. Next I'll get the same block which will tell me where is my connection. I'll tell voltage of order 0 under AI0. Everything is done. Then I'll go for connection diagram. Under this connection diagram, same 0 plus is given to my Vout, 0 minus is negative, and I have grounded my signal. Now I'll just give OK. It is building its VA. Now if you see, it didn't ask for me for a while loop because I didn't configure how many samples I need to acquire. So what I'll do, I'll just double click one more time and I'll just get into my DAC. Here I'll just specify I need to acquire continuous samples. A number of samples I'll just get say 1K at frequency of say 1K. The moment I am done, it will just calculate all this and it will give me the complete VA. Now what is happening here is that my system is ready, my sensors are ready, and my DAC is ready. See, last time I didn't get any pop-up window saying that confirm auto loop creation because last time I didn't specify what number of channels I need to acquire. So this time, since I've given it as while loop, so that it prompts me asking whether you want to confirm this, whether you want your VA to run continuously. Then I'll just give S. The moment I'm giving S, so my VA will just get into my while loop. So what will happen here is that I've done my VA, everything is ready. Now if I want to view this output, I'll just go to my front panel, right click, go for graph indicator, I'll just place my graph. So what I'll do, I'll just connect whatever data I want to see it in my graph. Now everything is done. So my IR sensor is ready. It has been powered up with VCC, ground, and Vout I have given to AI 0+. 0- is grounded and AGND is also grounded. Whenever you try to acquire some signals, you have two different set of connection. One is single-ended, one is differential. What do you mean by single-ended is nothing but whenever you want to acquire a signal with respect to ground, it is a single-ended. Now I have given a single-ended. What is a differential-ended? Differential-ended is nothing but when you want to have positive voltage as well as negative voltage. With respect to positive and negative, you get a differential. Here I don't want to go for a differential-ended. Like if you want to acquire say op-amp, it will have say 2 terminals, it is a differential. Now sensor, I'll take only a positive, so I require only one channel. So what I will do, out of 2 terminals to AI 0+, I'll give my IR sensor output. To AI 0-, I'll make it to ground, since I want it in differential mode. Now what I'll do, I'll just run my VA. See, can you just see the stream of pulses? Now whenever it goes to 5 volts, it means that your object is detected. It means it power ups to 5 volt. When now I am placing my hand continuously in front of my IR sensor, it means that it is completely detecting. Whenever there is no object found, it gives a 0 voltage. Now since you are not able to see, I'll just stop this VA for now. Always try to use this stop button instead of using this stop button, because this stop button will stop your iteration, I mean your execution, until the iteration is executed. But whereas this is not actually a stop button, it is an abort button. What this will do, example, your VA is executing, it is in a middle phase, at that instant itself it will come out of the loop, so that you will have a loss of data. But whereas this stop, it will, once your execution is done only, it will come out of the loop. Now what I'll do, I'll just go here, give 0, I'll make it as say 7 volts. Now I'll just right click, remove auto scale. Since you are not also able to see here properly, I'll even change my time period say from 1 to 0.5, and I'll remove my auto scale X also, so that whatever value it gives, it will plot within 0 to 7 as well as 0 to 0.5. Now what I'll do, once again I'll run my system, so that you don't find any fluctuation like how you saw. Now what is happening is that it is partially detecting and it is not detecting. Now it is not at all detecting. So you can just very well see you're getting completely 0 volts. Whenever it detects, now you're getting 5 volts. Sometimes you may not be able to see what is happening. So what you can do, you can stop your VA, right click, go for visible item. If you are using a chart, you can see even your digital display. Now this is the two different kinds of waveforms. One, this will give you a graph, this is a chart. Now here what I have mentioned here is that I want to even parallelly see what is my digital data. So the moment it starts running, you can just find now it is 5 volts, it is 0, 5, 0. It is because it's a train of pulses. So you obviously you get 0, 5, 0, 5, 0, 5. And this is how you can acquire any sensor related data from external environment to sensor, capture that whatever data back into your DAC assistant. So This is how you have to interact with any kinds of sensor, provided you need to know proper working voltage. If you're sure with your working voltage, you can just go on with your DAC assistant. If it doesn't matches, it is better to avoid not to connect to that. The worst part is that if the working voltage shoots above the voltage, there is a chance of your DAC getting spoiled. Thank you for now, and if you have any comments, please post it in the link.